All right, good afternoon, everyone. I want to thank you for joining us today. My name is David Fagerstrom. I'll be starting off the presentation, and we'll just get going here in just a second. All right. Thank you. Yeah, so as we get started, the first thing I want to ask is that everyone mute their lines. So please do so that we don't get feedback. We'll open it up at the end for anyone that wants to ask questions, or if you want, you can feel free to just type those questions into the chat as well. So today our discussion is for the Willamette Water Supply Program Water Treatment Plant, where Sundt is the construction manager, general contractor. Today we wanted to walk through a few of the specific scope of work packages that we will have upcoming for bid. If any of you joined us last week, you will have seen some of this information already, but we wanted to continue with an overview of the project and then get into some of the specific scope of work items for these packages to basically give you some insight as to what the bid process will be. All right, so quick introductions. Again, my name is David Fagerstrom, the Senior Project Manager for Sundt Construction. With me today, and that will be having some speaking parts in some of the slides, is first Michael Nair, who's one of our project managers, and then also Jared Wagner, who is another one. Each of these guys will have specific responsibilities on the project with me. Also with us today is Matthew Gribbins with the program. He is the project manager on the owner's side for the water treatment plant. Before we get started, I just wanted to ask that everyone on the call today to please type in your contact information in the chat so that we have a record of who joined us today, and then also so that we can make sure we have your contact information so that any future communications, we make sure that we get that out to you. I've typed my contact information into the chat, so you'll be able to find my email address there. And as we go through, Mike and Jared will also add their contact information. All right, so first we wanted to start out a little bit of who Sundt Construction is. So Sundt is a national general contractor. Our headquarters is in Tempe, Arizona. Looking at the map of the United States here, all the states that are either gray or red, we have done work in. So you can see that we've done work pretty much throughout the entire country. But our main focus of our geographic region is the states that are in red. You can see that pretty much goes from the Texas all the way through the south and the west up to the Pacific Northwest. Sundt Construction was founded first back in 1890, and we are a 100% employee-owned company. We have a few different divisions within the company. We have a building division that focuses mostly on your vertical type of construction. That's your high-rises, office buildings, healthcare, higher education, those types of buildings. We have a transportation division that focuses on roads, bridges, highways, those sorts of things. We've also got the industrial division, which is the group that our team works in, and that's focusing mostly on water and wastewater treatment plants. We also do some work in industrial facilities like copper mines, micro chip processes.
Yeah, manufacturing.
Yep, manufacturing. Also within the company organization, we have a self-performed concrete division that supports all of the different business groups. So our agenda for today, you can see we've got quite a few things that we wanted to cover. It's basically just an overview of the project schedule, the bidding opportunities that we have, and then some of the specifics associated with those bidding, with the bid opportunities, such as the instructions to bidders and the bid process and how you go about submitting a bid for this project. And today we're going to be focusing on three of the larger scopes. That's the concrete, the earthwork, and the process integration. This looks a lot like a typical pre-bid meeting. We're not calling this a pre-bid meeting. This is more of an informational session to give you guys an early look into the process so that you can see what's involved and be better prepared once we do advertise. And once we do advertise this for bid, we will have an official pre-bid that we will ask you to participate in. All right, so Sundt is very big on providing safe job sites. We always want our craftsmen to go home the same way that they showed up to the job site. And to support that, we always start out all of our meetings with a safety share. And so today's safety share is regarding innovative PPE. You know, Sundt is a company that we feel like we're always on the cutting edge of innovation, especially when it comes to things like technology, BIM modeling, 3D technology, use of drones. Those things are what you think of when you hear about innovation in the construction world. But today we wanted to talk about some of the innovation that we are working with our partners in PPE. And what we're showing here in the image is 3 hard hats, and what Sundt is going to implement on our job sites is the use of hard hats with chin straps. What we have found is that when working from heights, you are more likely to lose your hard hat, or the hard hat's going to fall off during that fall, and then eventually you'll end up hitting your head, and that's where some of the bigger injuries happen when working from heights. So what we've implemented is, like I said, the use of hard hats with chin straps.
Yeah.
It also prevents the potential for dropped items, right? So if you're working up at an elevated or a position of height, you may look up or look down, and your hard hat will fall off and fall to the level below you. So this measure prevents that from happening. As of right now, it is only required of Sundt personnel on our job sites, but it is strongly recommended that our subcontractors also consider using hard hats with chin straps. We're looking at 3 different options. The picture on the left, that's your mountain climber type of hard hat. Everything integrated. You can see it's even got an integrated like face shield or eye protection. Then you've got your other 2 traditional hard hats with the full brim, or just the ball cap style, where you can actually add a chin strap to the existing harness. So something to that you might want to consider in the future. All right, so we just want to do a quick overview of the project. So the Willamette water supply water treatment plant is made up of a pretty large program. The owner of the project is made up of 3 entities. Those entities are the Tualatin Valley Water District, the City of Hillsborough, and the City of Beaverton. All comprise the Willamette Water Supply Commission. The whole program is in the neighborhood of $1.3 billion, and it's made up of a raw water facility that pulls water from the Willamette River down in Wilsonville. You can see on the map, it's a pretty small map, so it's real hard to make out, but all the way down at the bottom there is the Willamette River. From the raw water facility, you've got a series of transmission lines. There's about 5 miles of pipe that heads to the north to the water treatment plant, and then about 25 miles of discharge or transmission piping beyond the water treatment plant. Also within the transmission piping is a separate reservoir or storage facility. So our project, though, consists of just the water treatment plant. Again, somewhat hard to see on this map, but we've got the arrow pointing to it here in Sherwood. So the water treatment plant is a 60 MGD brand new greenfield site water treatment plant, and it's being delivered through the CMGC delivery method. So what that means basically is Sundt was brought on real early in the project to work with the engineer, who is CDM Smith, and the owner to help refine the design through value engineering, optimizing the project, providing various cost estimates throughout the process to help deliver, a high quality project within the owner's budget. So zooming in a little bit closer, the project is located basically at the southwest corner of Southwest Tualatin Sherwood Road and Southwest 124th Street. It's basically a greenfield site that is heavily forested. The site was strategically chosen for the water treatment plant. One thing to note with the location is the site or the facility is pretty much all basalt rock. So what that means is when it comes to the excavation, there'll be a significant amount of blasting to be able to remove that rock. We are going to be working with several HJs or authorities having just jurisdiction. We've got some of them listed right here, the Oregon DEQ, Washington County, City of Sherwood, Tualatin Valley Fire Department. As I said, there are several, and we may not have all of them listed here, so we'll be working with a lot of different entities. All right, so this image here, this slide here, kind of shows the overall site plan of the various new structures. So quickly, I just wanted to hit on a couple of the stats. We've got about a 23 acre site. Again, all greenfield, nothing is there right now except a bunch of trees. The water treatment plant consists of several treatment areas, and I'll kind of walk through what some of those are in a couple slides later. We've got about a 15,000 square foot administration building. As with any water treatment plant, there's a lot of structural concrete. Based on our takeoffs, we've got about 40,000 yards of concrete. Earthwork, significant amount of earthwork. The middle of the site is kind of a hill. So obviously that needs to get graded out. So we've got about 65,000 yards of cut and fills, about 180,000 yards of structural excavation. For those of you that have worked on water treatment plants, a lot of the structures are deep tanks and excavated down on the ground, so that results in a lot of excavation. You'll see in some slides later that we've got a significant amount of underground piping, and with that, there'll be a lot of excavation associated with that. We're calculating in the neighborhood of 120,000 yards of pipe excavation. In addition to those components, water treatment plant requires lots of specialty equipment to treat the water. We're estimating we've got about $20 million worth of process equipment. Once the water is treated, there's up in the top right of this image, you see a big round circle. That is the finished water storage, the clear well. That's a 10 million gallon pre-stressed concrete tank. Throughout the site, we've got a handful of pre-engineered metal buildings. And all this is to say that we've got multiple building trade opportunities, roofing, painting, structural steel, flooring, drywall. So lots of different architectural building trade type opportunities on this project. All right, so zooming in a little bit further, wanted to kind of walk you through the layout of the facility and kind of the treatment process real quick. So this image right here is a 3D model of what we kind of call the process building. Over in the back left, you can see the call out for the administration building. That's that 15,000 square foot building that I mentioned. That's where your operations staff and members of the ownership group will have their offices. It's also got a lab facility in there where they'll do their their testing of the water quality and things like that. To the right of that is really where the water comes into this facility. That's the ballasted flock process area. After the ballasted flock, to the right of that is the ozone generators and the contactors. And then the water flows from there over to the filters. That's where the fine particles is removed from the water prior to going down into the UV disinfection structure, which is just the lower part of the picture of where the filters are. In addition to those treatment processes, there is some chemical addition and adjustment to the water. So on the bottom left, the big dark rectangle, that's where the chemical facilities are housed, the main chemical, the indoor facilities, and then to the right of that is your outdoor chemical, which is your CO2 and liquid oxygen storage. So let's go to the next one. All right, so we have two images right here. These images are of the same structures. The one on the left is basically looking out across the EQ and the clear well from the vantage point of the site. The image on the right is basically standing on the corner of Southwest 124th Street and Southwest Ore Drive. Southwest Ore Drive is the street that runs off of 124th and kind of goes along the perimeter of the site on the north and west sides. But looking at the picture on the left, in the front here at the bottom, you've got the EQ overflow. That's basically a large, deep structural concrete tank. Again, that's excavated in rock. Lots of concrete used for storage of overflow water. Then in the background, that's your round tank. That's the clear well that I mentioned. Again, it's a 10 million gallon pre-stressed reservoir. To the right of that is the finished water pump station. This is the structure, the process that houses some pretty large vertical turbine pumps that distribute the water through the transmission lines. That finished water pump station is a pre-engineered metal building. And then I guess to the right and towards the middle of the image is the equipment storage building. This is another one of the metal buildings on site. This is basically a large storage building. It's kind of like a big open shell for the operations to store their equipment. Last area we're going to look at is the solids handling facilities. As you treat the water and filter it, small particles get pulled out of the water and accumulate, and you need to manage those particles or those solids. To do that on this site, they are sent over to the solids handling. In the front of this image, you've got two circular tanks. These are the thickeners. They basically have, they're like big settling tanks that have large, like circular clarifiers that help settle out the solids. From there, going up towards the top of the page, you've got the thickened sludge pump station. That pumps the sludge into the thickened sludge holding, which again is another structural concrete like storage tank. And then from there, the solids is extracted from the water in the solids dewatering building. This building has a couple of screw presses in it, to where again the water and the solids are separated, and the solids get loaded into trucks and then hauled off site.
All right, so now we're going to go over project schedule, and this is a very rudimentary schedule that we put together, which aligns with a detailed P6 schedule that we have already created. And specifically for this meeting, we wanted to highlight the key areas that we're talking about today. So earthwork and yard piping are the two areas in green. the area in gray that just filled in is what our durations for concrete are expected to be. And then last but not least, the process, mechanical, and equipment. So as you can see, really these three scopes that we're talking about today do cover multiple years of scope of work, and we'll go into a little bit more detail of what those scopes entail. I just want to go over the bid schedule and bid opportunities. So talking about the bid schedule, for those of you that did sit in on last week's initial kickoff meeting, we were reflecting 3 GMPs. A recent change that has been decided from the program is that we are going to merge GMP 1 and what was previously documented as GMP 1 and 2 into a single GMP. So that is now referred to as GMP 1. And then we will have a later GMP 2, which is to be more for back-end type work, landscaping, hardscaping, sidewalks, asphalt at the very end of the job. So we just wanted to convey to everyone that GMP 1 is going to entail 95% of all the scopes of work, including the 3 scopes we're talking about today. Right now we're expecting to advertise mid-October. We'll have a pre-bid kickoff meeting within a week or 2 after initial advertisement. And then really, having a R5 deadline mid of November, addenda deadline early December, and bids would be due in mid-December. Like I said, this was a recent change that the program and Sundt have decided on, and we will, once we fine-tune the exact dates, we will be re-advertising that information both on the Our Reliable website and then also on public notifications that you all may receive. So right now, as David had mentioned earlier, project delivery on this is CMGC. And one of the benefits that this provides is that we've done a lot of cost modeling throughout the life of pre-construction, which has given us the ability to kind of do some guesstimates on where we feel that the costs are going to be coming in at. So what I wanted to key on here for you all is, right now we're anticipating the concrete package to be, roughly the mid to high 30s, $30 million range. As we mentioned earlier, it is 40,000 cubic yards of structural concrete. The process piping division 40 scope, we've estimated is right around the low 30s, low $30 million range. The underground utilities and yard piping, right now we're looking at around mid-20s, and the earthwork is around low 20s. So as we'll go into further detail in each of these packages and what the scopes entail, but just want to share this with you all. And specifically for this meeting, what I wanted to show to you all is kind of all these areas or scopes are in GMP 1. We anticipate that these will all be issued as subcontracts. And another thing we want to be able to convey to everyone is that Sundt is intending to bid competitively on each of these packages. The concrete packages, earthwork site utilities, and the process integration have been designated as best value. And we'll go into what the process of best value means here in a few slides. So instructions to bidders, exhibits, and attachments. So for those of you that sat in last week's meeting, we went through this in a lot more detail, so I'm not going to take up too much of your time. You're more than welcome to refer to that presentation, which was recorded and is now available on the Our Reliable website. But part of each of the bid packages will provide detailed instructions to all the bidders that explains, what each step is, the milestones, bid dates, and more in particular, exactly what we need from you all to be considered as a responsive bidder. We'll have detailed scopes of work for every single work category or a division, if you want to call it that. That we have very detailed of what's included in your scope and also what's excluded out of your scope to provide very clear lines of your scope. A specific bid form, exhibits and attachments, which I'll go over here in the next slide or two. A construction schedule, so we will provide a detailed P6 Primavera schedule in a Gantt chart format. All the drawings and specifications, geotechnical reports, and other supplemental information such as site logistics and laydown plans, excavation, stockpiling plans, etc. The instructions to bidders, again, going a little bit more in depth of what this entails. I'll let you all read it, but if you want more information on that, we will go in much more depth into this at the official pre-bid kickoff meeting, but you can also refer to last week's outreach meeting that we had. And exhibits and attachments, really the key thing on this is really all the information that will be provided to you at bid time. And one thing we do want to reiterate is that attachments will not be rolled into your contract, but all of the exhibits, all the information that's entailed into these exhibits will be attached to your subcontract as we move forward. And a lot of this really just, again, defines what the scope of work is, what's expected of you, what's expected of us. One thing that I think to point out here is that this job is a WIFIA, has received WIFIA funding, which WIFIA is a federal program for water and wastewater work. And because of that, we are tied to Davis-Bacon wages, as well as because we are within the state of Oregon, we are required to follow BOLI, which is Bureau of Labor and Industries within Oregon, which we are also tied to certify the prevailing wage rates. So, and again, these exhibits will go into that detail as well as the instructions to bidders. So, and if you all have any questions on this process, more welcome to reach out to Sundt or the program.
Yeah, one other thing on this with the WIFIA that Mike mentioned is we have a requirement to utilize American iron and steel. So I see that we've got some concrete reinforcement companies, concrete companies on the call with us, which is great, and you guys are probably already familiar with that, but just wanted to highlight that it's AIS requirement as well.
Yep. So next, we're going to go over the best value process, the submission, evaluation, grading, and selection. And on the phone with us today is Matt Gribbins, the project manager for the program, and we wanted to have him speak on this process on behalf of both Sundt and the program.
Thanks, Mike. Okay, so first off, we just want, as the program, to let all potential bidders know that the program is interested in, getting really the best qualified, best value on these packages. And so we're going to be receiving all of the bids related to the best value packages, which include the 3 packages that we're talking about today. There'll be further directions in the bid documents on how to do that, so that those bids come in actually to the program. The program will be opening those bids, and then they will include both, like Mike mentioned, I think both a qualification and a cost component. Again, we'll open those privately and record the bid results as the owner. So go ahead to the next slide. The qualifications part of it is just meant to make sure that we have subcontractors performing the work that are qualified to do the work. And like you saw on some of the slides, this is pretty complex work when it comes to the concrete and the process mechanical and the piping. Not your typical office building or anything like that. It's much more of an industrial kind of construction. We're trying to make sure that the qualifications part of the bid is not too onerous for the bidders. So we're thinking we're going to probably limit that to maybe maximum of 15 pages or so, and that'll be defined in the RFP when we send it out. And then general things that we'll be looking at include the things in the list here, just general information about the firm, experience and qualifications for this type of work, the experience of the key personnel on this type of work, understanding of the project and approach to performing the work. Some of these, potentially have some, areas where the bidders could come up with some good ideas that we'd like to consider. And we'll talk about those a little bit maybe when we get into the individual projects, but we would want to hear about those. And then safety records, approach to safety, and references associated with the previous work and the work of the key personnel. Each scope of work will have its own bid form. Bids need to be submitted on that bid form because that's how we're going to make sure we're comparing apples to apples as we compare all of the bids. Sundt will, once we open the bids, compare the bids just to make sure that the entirety of the scope was included in the bid, and if it wasn't, then to look at how do we level the bids to make sure that we're capturing all the same scope as we compare the pricing of the bids. They call this process abstracting, and then once they do that, we will review that with them to make sure that we agree that the abstracting was done correctly and that we're comparing apples to apples across all the bids. We will have a 1,000-point grading system basically. So there's a list there of the items that'll go into that. We're still finalizing the percentages of that will be included. I will say that pricing will be a significant portion of that 1,000 points. And then we may choose to hold interviews with select firms in the different packages if we want to follow up on any questions related to the bid or discuss anything further that we have either questions about or concerns about. So again, the pricing will be a large component, and then the other bullet items there roughly correspond to the items that would be in your proposal that we talked about on one of the previous slides. Okay, so, and again, in the interest of this being a fair, competitive bid, knowing that Sundt plans to bid on these 3 work packages, we welcome any comments or questions you might have about the bidding process. If you think that there's something that's not quite fair or whatever, feel free to contact either Sundt or myself about that, and we'll try to address your concerns.
Awesome. Thank you, Matt. All right. I'll turn it back over to David.
All right. So seismic design, seismic qualification. So one of the reasons behind this project is to build a seismically resilient facility. The program, wants to be able to provide water services to its customers within a certain time period, should there happen to be a seismic event. And so part of that is a seismic qualification process. And I'll just start out by saying that it's probably not as big of a concern or challenge with some of the scopes that we are talking about today, but I do want to highlight this real quickly so that when you do get the documents, you do look at that, because there is a component related to some of these scopes, especially the process mechanical. So we have a Division 1 general requirements spec, just like you find on every other project. So we have a spec related just for this topic. It's the 01-8829 seismic performance requirements. And the spec starts out by stating that it includes architectural, fire suppression, plumbing, process mechanical, building mechanical, and electrical components and systems, non-structural components, and non-building structures. So that covers the majority of the project. And as I said, depending on your scope, it's got a different level of involvement or qualification. But there are three ways to achieve the qualification. The first is analysis. That's your typical engineered analysis calculations, done at a computer, calculating reactions and things like that. The second method is through testing, and this testing piece applies more towards your electrical and process equipment components. But essentially what this is asking is that you take the physical piece of equipment and test it on like a shake table to a certain magnitude to verify that it's engineered sound and could withstand those forces. The third method is through experience, and that's basically if a manufacturer of a product, a piece of process equipment, an electrical cabinet, a valve actuator, has had their equipment actually go through a seismic event, an earthquake of similar magnitude. So those are the three ways to achieve qualifications for the seismic requirements. Again, it's not as big of a process for these scopes, but we will highlight this again and direct you to this spec. Speaking for the process mechanical scope, a big area for this is, like I sort of mentioned, the valves and the actuators.
And pipe supports.
Yes, and pipe supports.
Yep.
The big thing to note here is when someone says, you got to do seismic calculations, they immediately think of just anchor bolts. So anchor bolts for pipe supports, anchoring electrical cabinets to the ground, process equipment to the ground. This is significantly more than that. If you've done work in California, you may have experienced similar requirements. So there's a lot here. Don't want to go into all the details other than just highlight that we are going to direct you in several places in our bid instructions to review these specs and make sure that you're in compliance with these requirements.
Yep. And when we do the official pre-bid kickoff meeting, we will go into the seismic qualification much more in depth. As David said, this does not apply too much to structural concrete and to earthwork and yard piping, but there may be a few components called out within specifications that do refer back to this, requiring some sort of analysis testing or experience is needed. All right, so now we'll get to the meat and potatoes of why most of you all have called in today. We'll be going over each division, talk about the scopes of work, kind of go through the overall scope, but then also talk about a few items or areas of concerns that we see that we just want to convey to you all. So Division 3, Structural Concrete. So as part of this package, it includes all divisions of the 03 specifications, including reinforcement. We just wanted to reinstate that because sometimes there are some concrete installation companies that just do formwork and placement and no reinforcement. We're expecting that the costs include all reinforcement. The scope, like we mentioned earlier, it's about roughly 40,000 cubic yards of concrete spread out across over 20 structures. We are considering to split this overall package into 3 packages due to its overall size. And because of local, we received some feedback from local contractors that are interested in the job, but are unable to pursue a job of this size. So with that said, we'd love to get feedback from you all to see, if this scope is manageable for you, if you support splitting it into multiple packages. We'd love to hear back any feedback you have, and I'll just leave it at that. Another item required by spec is that the mix designs are required to be NSF certified, which is a lengthy, tedious process for the concrete suppliers. So we just wanted to kind of reiterate that here, as well as the specs do call out that the finishers have to be ACI certified. So whoever's doing the placement and finishing needs to have a program in place that's able to train their employees and to receive that ACI certification. As part of this scope, there are, unlike typical commercial type work, there is a lot of embedded items that go both within walls and slabs. Regarding anchor bolts, pipe sleeves, wall spools, which are part of part of the process piping, and hatches. Involved in this scope of work is included setting of all these items within your placements, as well as water curing of all the water-containing structures. So with that process, you're not able to use, on water-containing structures, you're not able to use membrane cure type curing methods. You have to use a water cure method, which is explicitly detailed within the specifications. On non-water bearing or water-containing structures, you are allowed to use membrane cure as well as a couple other specified processes. But we just want to point out that water cure method is required for water-containing structures. There are multiple water-bearing structures involved with this project. Obviously, that's the sole purpose of this job is to move water and clean it. So each of those water-bearing structures requires hydrostatic testing. We do have a specification that calls out explicitly, how to follow ACI standards for hydrostatic testing, and the methods that you have to do for that. We also want to point out that the ozone contactor requires hydrostatic testing as well as gas testing, which is actually pretty normal for this type of structure. The gas testing tests both pressure and vacuum. So earlier I mentioned, we talked about breaking the scope out into 3 potential packages. And this is where we'd like to really hear back from you all. So what we have, all of the structures highlighted on the screen are what have structural concrete. The blue one, the big round one, is the clear well. That one is, because it's a very specific type of construction, is not part of this Division 3 structural concrete. It is its own work package. But the structures surrounding it, which are in the green there, which we refer to as the finished water and EQ structures, those are part of this package. What I want to convey here is, right now I said there's roughly 40,000 cubic yards of concrete. We'd love to be able to hear back from you all of what your firms are able to feel comfortable with pursuing. If it's all of it, which is great. If it's less, really depending on your experience or your bonding capacity or just your comfortability, please let us know. So the 3 packages we do plan on doing, or that we're proposing or contemplating, is the main process and admin building, which is in yellow. And then the pinkish purple color is the solid structures. And then the green, as I mentioned earlier, is the finished water and EQ structures. They're clear delineated lines in between those 3 scopes of work that we think that would make for manageable sections. The thickeners, the solid structures would be roughly around 10 to 15,000 yards. The finished water EQ structures would be right about 10,000 yards, and then the main process building and admin will be right about 20,000 yards, 15 to 20,000 yards, in that range. So again, as we mentioned, we'd love to hear feedback from you all, what your thoughts are. So following along lines of the proposed separation of this scope, so I want to focus on the main process structure and admin building. So as David mentioned earlier, this structure is it really includes like 6, 7 different processes. Kind of right here in the middle, toward the bottom of the picture, that is your filter structure. The filter structure includes sideline grade as well as a deeper pit in the center there, which is where your main process utility corridor is. And then you have your filter basins on either side of it with large 30-foot tall concrete walls. You also have the ozone contactor, which is just up from the filter structure, which again is also another large water-containing structure. That is the structure that also requires the vacuum testing along with the hydrostatic testing. And then you also in the structure as well, you have the UV treatment pit, which is a pit that's about 20 feet down into the ground. That's really the deepest area of this entire process facility, but this building does have a lot of vertical walls and water-containing structures.
This structure is probably the more complex, especially when it comes to concrete. For anyone that's done things like filters and ozone contactors, you know that you have to break down and rebuild your forms multiple times because your wall lengths are different, your heights are different. You're pouring a wall, then you're putting a suspended slab on top of it, and then another wall on top of that. So this is probably your more complex structural concrete scope on the job.
Absolutely. Kind of a different view from the opposite side of the previous picture. At the bottom of the picture there is the administration building. This administration building has a lot of spot footings, grade beams. The slab-on grade is all at one elevation. There are areas of polished concrete floors, which will be part of this scope of work. There's also some areas of recessed flooring for different flooring types, ceramic tile flooring, carpeting, and like I mentioned earlier, the polished concrete floors. Just above that and to the right, this large rectangular structure here with the roof, you can kind of see that is the main chemical building. That is a fairly large chemical structure where it's got multiple containment pits within there. Most of all that concrete is due to receive chemical coatings and chemical paint protection on it. And there's a lot of, I'd say, cut up concrete work within that area. Like I said, there's a lot of containment pits. So, you have lower slab-on grades with pony walls that bring you up to a higher elevation, another slab-on grade there. You have delineation walls and fall protection walls everywhere. So when you do get the documents, it is a pretty cut up and multiple pours within that area. Even though it's not a tall structure, it is a pretty complex structure.
There's not a whole lot of quantity, but it takes a long time to build.
Yes. Yep. Next, we'll go over the solid structures. So you have the two thickener basins, which are the two round basins on the left-hand side there. Each one of those are, I believe it was roughly 100 foot in diameter. They are recessed into the ground about 10 feet, and then the walls in total are about 18 to 20 feet tall. One thing to point out is the slab-on grade does slope from the high point being on the outside of the circumference of the circle, and going down to the center of the circle is where it gets deeper there at the pit. Just to the right of those two structures, it doesn't really give it much justice, but in the model it just shows this little structure here in the middle, which is the solids pumping station. That is actually about a 25-foot deep structure that is buried in the ground. Really, it's really just a box in the ground. It's not a water-containing structure, but does have some vertical concrete walls. The next structure over from that, which is the tall concrete structure, that is the solids holding structure, and those walls are about 20 feet tall. It's got 2 basins inside of those, really just meant to hold water, so that is a water-containing structure. And then the structure on the far right-hand side, which is the tallest structure in the picture, that is the dewatering structure. That really just holds equipment and piping, as well as it does have a raised floor. So it has a second level deck in there, a concrete deck, and the trucks drive underneath there and receive the cake or the solids that come off of the screw presses. So really what you see here is that the 2 large thickeners that are water-containing structures, and the solids holding structure that are water-containing structures. Next, to go over the finished water and EQ structures. Again, just want to point out that the large circular clear well is not a part of the Division 3 structural concrete. That will be its own separate bid package. As David mentioned earlier, the large rectangular structure in the bottom left-hand corner is the equalization basin, EQ basin. Really, it's just a large water-containing square rectangular structure. Nothing really too difficult, other than it is a water-containing structure. Kind of close to, in the middle to the bottom of the picture is the small pre-engineered metal building. That's just a simple slab on grade, not too difficult. Just above that, you see kind of coming out of the ground, it looks like it's some of a short structure, but that is a deep EQ overflow basin. Sorry, not overflow, splitting structure. Oh, it is overflow splitting structure. That is about 30 feet deep. It goes 5 feet above ground, 20 feet below ground. And that is a water-containing structure. This next structure over here, we see kind of the 3 teal-colored cylinders and the 3 gray cylinders on it. That is the surge mitigation pad. That is really just a thickened slab on grade with turned down edges. And then on the far right-hand side here, the tall structure, that is the finished water pump station. That has almost a 40-foot deep clear well finished water pit. And then that 40-foot, once it comes up to slab on grade, it expands out into the large structure you see there. And then there is a second level cast in place concrete mezzanine that goes in that structure as well. And again, what David had mentioned earlier in why we wanted to cover this Division 3 scope of work is that water wastewater does involve very complex type structures that are engineered with a purpose. And these couple drawings and snippets from the construction documents just show how there are multiple elevations in the slab on grades, numerous vertical walls, as well as there's areas of concrete fillets that we call basically where you have to grout back some of the structures in order to be able to have the water slope correctly and flow correctly as it's designed. So we really just want to impress upon everyone that this isn't your typical vertical construction type high rise or healthcare type work. This is very complex work. So again, this is why we've designated this as a best value package, because we want to make sure that the people that are bidding this understand the scope of work, understand the risks associated with it, and making sure that we have the right partner on board.
Yeah, a big thing with the concrete scope is, you're not just the concrete sub out there focused solely on your work. You've got embeds, pipe running through different walls, popping up out of slabs. So as the concrete sub, you're coordinating a lot with the process integration, electrical, all these different subs. So the concrete scope is an integral piece to successfully getting this job built on time.
Absolutely, good point. All right, next we're going to kind of switch gears, go over to the earthwork and utilities, and I'll pass this off to Jared.
All right. Thanks, Mike. So Earthwork and Utilities is Division 31 and 33. For our work packages, we're going to be combining these two into one work package. So Earthwork and Utilities are going to be bid together as one work package. For the sake of the slides today, I'm going to break it back apart into its disparate elements. We'll talk about Earthwork first and the utility second. So under the Earthwork scope of work, we would own all the Division 31 specifications. So everything in that Div 31 would belong to the Earthwork. Getting into the scope of work and the SOW, there's approximately 23 acres of logging, grub and clear, which is one of the initial challenges on the project. There's quite a bit of vegetation on the site, including some poison oak on there. So that'll be a bit of a challenge. Drilling and blasting, as we mentioned previously, the site is built on a lot of basalt outcropping. So there's quite a bit of drilling and blasting to be done on the site, about 65,000 cubic yards of cut to do, as well as 180,000 cubic yards of structural excavation for the drilling and blasting scope. That rock would need to be crushed to meet backfill specifications. We actually have 3 different specifications that we'd be trying to meet by crushing this to get it down to a usable size. I will take a moment to say that at the subcontractor's discretion, they could choose to haul off the crushed material or haul off the material and import material at specification at their own discretion if they find that to be the most cost-effective strategy for them for your bid. The scope would also include acquiring the blasting permit, and this plant is at its initial build out is going to be a 60 MGD plant. At some point in the future, there's an expansion to bring it up to 120 million gallons a day. So the scope would also include drilling and blasting for those future structures in order to upsize the plant at a later date to get it up to that size. That way the future constructor doesn't have to work through that basalt. Earthwork scope is also going to include setting up all of our temporary roads, lay down and staging areas, and getting those prepped for us. Includes all of the site grading. There's a number of LIDA ponds or light impact development area ponds, basically stormwater retention ponds around the site, receive a pond liner. So that goes within this scope of work as well. Earthwork would own the structural backfill against all the structures once the concrete's completed, as well as doing the road subgrade to getting it within a tenth. And that includes all the curb and sidewalk as well to get it that subgrade taken care of. All right, so for the clearing and grubbing site setup, we looked at this in a basically a 3-stage process. The site entrance is off of 124th Avenue on the right. So the first stage would be that initial grub and clear, just to get our subcontractors, equipment, and personnel into the site. We'd establish the initial survey and benchmarks and start working on tree protection as you start working your way in, as well as installing the erosion and sediment control plan as you work your way in. The second stage is bringing that haul road around the northwest corner down to the southwest corner, and that gets us our access into where our temporary construction trailers and our road and laydown area is going to be. Once that second stage area is cleared, grubbed, and set up, then we'd be moving into stage 3, which is the main process area, in getting that cleared and grubbed and ready to go. Once all that's done, we'll get that security fence installed and get rocking and rolling on the blasting. So let's take it to that next slide for the blasting. So in terms of blasting, so this is a heat map showing the difference between cut and fill. The blue areas represent areas where fill is ultimately required based off the existing site conditions, and the red represents excavation based on the existing site conditions. So you can see most of this area and most of the volume here is going to be a whole lot of cut overall for the site. So on the Structural excavation, we're looking at 125,000 cubic yards of structural excavation. And then for the site fill, you're looking at 56,000 cubic yards of excavation and 66,000 cubic yards of embankment. One of the challenges as we dig into the scope for you to take a look at is exactly where this crushed material is going to be heading to. So according to our project schedule, once we have this area grub cleared, blasted, and ready to go, we're going to want to start handing these areas over to the Division 3 to begin the concrete work. That's going to limit the amount of available on-site storage space for this material as it's waiting to get crushed and used as structural backfill. So that's one of the things that we'd be looking to the earthwork subcontractor to work through and figure out a solution for what to do with the extra material pending it being installed in its final location or ultimately exported from site. So scope of work for the utilities, again, we're going to include all of Division 33 specifications into the utility scope, and that's going to include the underground utilities, your potable and non-potable water, sewer, storm drain, as well as the process piping for the actual process of the plant. So that includes installing as well the temporary construction water system. So getting the temp water for the dust suppression, as well as hooking it up to everywhere that we're going to need temporary water connected to. The scope of work for utilities combined with that earthwork also includes drilling and blasting for those underground utilities, which adds about 120,000 cubic yards additional for those utilities. Again, crushing to meet the backfill specifications for that and acquiring the blasting permit, and that can all be done together with that earthwork. The utility subcontractor would also include owning the purchase of all that underground pipe, the manholes, the appurtenances, and everything that goes with that. That includes doing the concrete encasements once that's placed, and doing the successful pressure test and disinfection of all the piping systems before we backfill that. So the pressure test and disinfection would be on the utilities work before we cap that and bring it inside the structures. There's also some yeah, go ahead.
Jared, just to clarify that, we probably won't do the disinfection until the end of the project, so it'll probably be primarily the pressure testing. Okay,
thanks, Matt. Appreciate that. And then owning precast chemical and containment vaults as well. All right. So to give you an idea of some of the scale of the work of the job, so the dark lines show where some of the underground utilities are. In terms of quantities, a rough takeoff for those, we have a carbon steel pipe that ranges from 1 inch to 84 inch. We've got about 2,800 lineal feet of that. The CCF pipe is like a fiberglass reinforced polymer pipe. There's 1,200 feet of that, ranging from 48 to 84 inch. Ductile iron is going to be the bulk of the pipe on the job, ranging between 6 to 14 inch. 14,000 lineal feet of that. And then PVC, CBVC, 1 inch to 18 inch, 7,500 lineal feet, and a little bit of HDPE between 4 inch and 6 inch. There's 570 lineal feet of that, just to give you a scale of some of the underground utilities that are going to be going in the site. Some of the challenges on the job are going to be relative to the coordination. On the left-hand side, what we're looking at here, that dark gray structure, that's the finished water pump station. On the right-hand side is the clear well, and at the bottom of the clear well, there's a sump. So this short section of piping connecting the finished water pump station to the clear well sump is going to involve that underground utility coordinating directly with both the clear well and the concrete subcontractor for both structures. It's a complicated little piece of pipe to put in. And let's go to the next one. And same on the other side of the structure. So this is connecting the clear well overflow structure to the clear well sump at the bottom of the inlet there. So again, you can see some of the challenges in coordination of getting that into both of those structures, as well as the layers of utilities in the area. And then let's flip over one more. So what we're looking at right here on the right-hand side is the clear well, the 10 million gallon clear well, and on the left, far left, is the end of the process building. This is probably the most congested corridor for underground utilities in the site, this little area right in between there. the point here is that the underground utilities and earthwork scope is going to require a lot of integration and coordination with the rest of the subcontractors on the job, and really digging in and figuring out the sequence of installation. The red lines you're seeing there are electrical duct bank. You can see some of that is going above or below the process piping. We've got plumbing lines, sewer lines, and process piping all working its way through this main corridor and main intersection area here. All right, with that, I'll hand it back over to David to talk about Division 40.
Yep, so the last topic for today is Division 40, the process integration or process mechanical scopes. So I just wanted to walk through just at a high level of what is included in this bid package. The full details of this bid package will be clearly listed out in the scope of work document. That's the Exhibit A of our bid docs. And what you'll find when these are issued is that the process integration scope is going to include the supply and installation of all the process piping, fittings, the valves, and the pipe supports associated with that. It'll also include the installation of your inline instrumentation devices. We're going to have a document that will help delineate the supply of the instrumentation. I guess for talking purposes today, the majority of the instrumentation will be provided in the electrical scope. But as I said, there's several inline instrumentation devices that will get turned over to the process integration sub for installation. In addition to the piping, the process integration sub will also be responsible for receiving, storage, and installation of the process equipment. Procurement of that equipment will be by Sundt through the CMGC process. There'll be a similar bid process to procure all that equipment. But once that is done, it will be turned over to the process integration sub for installation. The way I look at it is basically the process integration sub, owns that equipment all the way through the manufacturer's certificate of proper installation. So there's support associated with that where we'll have the manufacturer on site for installation checks, and the process integration sub will support that in making final adjustments of the equipment to receive that certificate of proper installation. There'll also be a component in this scope for commissioning and startup support. To do the startup of this project, we have to install some temporary piping to be able to circulate the water in loops and do the various checkout and certification of the installation of the process. So that'll be part of the scope. We'll also ask that this scope successfully pressure test all the piping systems, and then disinfection of the various piping systems and structures that need to be disinfected. Similar to what Jared showed on that one 3D layout of all the yard piping that runs in several directions at different elevations, with this scope, we'll have that same thing where you'll be coordinating with the electrical sub, your HVAC sub, plumbing sub, all those various components to make sure that everyone is able to install their systems where they need to go. So part of this scope will be a certain level of BIM coordination, which again will be spelled out in the scope of work documents. Next slide. All right, so similar to the other scopes, we wanted to highlight some of the more challenging aspects of the project and the piping installation. So this image right here is looking down the filter gallery. We've got 8 filters, 4 on each side, and this gallery is basically kind of the interconnection of all the piping. This gallery has concrete walls on each side. It's got a concrete deck. So what we'll do is work with you as the CMGC to identify ways to stage some of this piping within the gallery, possibly get some of it installed before the deck goes on. But the other nice thing about this structure, as challenging as it is, this bottom slab here, it's not too deep in relation to the surrounding grade. And actually right where this image is taken from, this vantage point, is an end wall where we'll likely plan on leaving that end wall out and allowing you the opportunity to kind of ramp down into the structure to where if you wanted, you could access and stage some of this pipe with a small forklift to help do the installation. But again, you can kind of see at the top of the image the ductwork that's in here. Of course, you're going to have electrical and all those sorts of things running down here. So again, this kind of shows the coordination between all the scopes. This next image here is of the main chemical building. While a chemical facility, chemical building doesn't have your large diameter prefabricated pipe like what we had at the filter gallery, it still poses its own challenges. You can see that there's several large storage tanks that need to be staged in here. This is another thing. We'll work with you to try to get these tanks installed, likely before the structural steel roof goes on. But once that's done, you've got quite a few miscellaneous pumps that sit on pedestals, and then as small as this part of the process is, or structure, there's several thousand feet of pipe that runs through here, various types, mostly your plastic type pipes, some double containment pipe. And again, there's lots of coordination between the various trades. So again, this is another reason for the BIM integration and coordination between this scope and the rest of the scopes that we'll ask you to do. All right, so that brings us pretty close to the conclusion of the information we wanted to present today on mainly on those three bid packages. I just wanted to point out again that this information can always be found at the Our Reliable Water website. It's where we've got kind of a fact sheet information on the project, the bid process, and then down at the bottom we've got this table here that we're showing on this slide that shows the dates for future meetings that we are having to run through the other divisions in a similar fashion to bring awareness to the project and kind of show the challenges and the bid process that we'll have. For those of you that weren't able to attend the meeting last week, which was more just a general overview, there is some overlap between that meeting and this meeting, but if you wanted, you could click the link there and watch that PowerPoint slide as well.
All right, so that's really the end of our presentation today. Just want to open it up for open discussion or any questions that you all may have.
Yeah, and feel free to unmute and ask your question. If you'd rather just type it in the chat, that will work as well. So we'll just hang on here for a minute if anyone has any questions. Okay, well, doesn't seem like we will have any questions, but we've posted our contact information. Feel free to reach out to us later today, anytime here in the near future. This will be going out to bid pretty soon, so you'll see an advertisement early mid-October for the actual bid process. So we look forward to you participating in that. The reason we ask for your contact information now, again, is so that we can add you into our system for sending out any additional notifications to keep you informed of the process and the project.
Yep. Well, thank you, everybody. Appreciate your time.
Thank you.